I don't know anything, and I will be asking you guys today, how should I approach a specific problem? Okay, so today my first problem will be to get a camera started on a robot, on a Raspberry Pi or on something like this. Okay, so first thing is to connect to the robot. That is the simplest thing that we need to start with. I will stop this simulation, whatever is going over here. Give me a moment. Yeah, and I will simply connect to my robot. There you go. So we are into the robot today. Okay, so yeah, can you guys see this screen? Just let me know, because
Yes, sir.
Yes.
yeah, okay, great.
Yes.
I will just set everything else up over here. Yeah, okay. So there you go. So this tortoise bot comes with a camera on board which runs the ROS image. Okay, so if you want to check that, I will first show you what is the output. So if I start ROS launch, tortoise bot firmware, and if I do bring up dot launch, it will start the camera and it will start the lidar of the robot. So this is pre-made. So just a minute, due to some reason the Raspberry Pi camera node has died. Just let me restart it. Let's do one thing, let's start it from start. So whenever you are getting camera started on a Raspberry Pi, what usually you do is you put a sudo raspi config. So I will do sudo raspi dash config, and I will go into interfaces. Here we will be starting with camera. So I will enable camera. Yes, I would like to enable it. Camera interface enabled, and I will finish it. So that's it. Now, after doing that, we have to reboot it. So I will just reboot it once. Sudo reboot. Let it load. Until then, there is one more way you can do it. Is using not these things. What we say? USB camera. So if you have a USB camera, everything sees it in like a USB interface, but you have to convert it into ROS messages. So there is a package for that. So if you see USB camera, ROS, yeah. So there is a package for this called as USB cam. Like in the beginning days, Lentin Joseph had a talk over here at Takshak. So in this event itself, he has explained how to use it. So you can, and that video is available on YouTube, I guess, on Takshak's YouTube channel. You can go and check it out over there. But if you clone this repository, yes, so it has all the launch files and everything which is required. So what does it do? It takes your USB webcam and it converts it into a proper ROS image which you can view. So let's try it out. I am not sure if this works on ROS Noetic or not, but let's check it out. So I will test it on my own PC. I will stop my USB webcam over here so that I can access it through over there. Oh, okay, I will copy this thing and into my SRC. So I will go into SRC, CD, Catkin workspace, SRC. And here I will do git clone and I will paste the link. Okay, it is cloned. Yeah. So now what I will do is I will simply launch the launch file, which is ROS launch, the name of the package, which is USB_cam, and the name of the launch file. Cannot launch node type, cannot locate node in package USB cam, make sure file exists. Okay. Okay, so maybe it is not executable. Let's check that. So if I go into src, these are the source files. Okay, so these source files need to be executable. So I will go into the package USB cam and cd src. If I do ls, you can see this is in white in color, means it is not executable. So I will, as the it is suggest. So this is the one of the like important features of ROS which I like a lot, which it tells you what to do. It doesn't ask you like this is an error. It also gives you the solution. So it says sudo chmod. So what I will do, chmod plus x and the name of the file, which is usb_cam.cpp. Now if I do ls, this has been turned to green. Turned green means it is executable now. So now if I run the same command which I did previously, it should work. Okay, it's not worked again. Let's do a catkin make. I will go back into catkin workspace and I will do catkin_make. Sorry, spelling mistakes. Yeah, let's wait for it to build. Yeah, so many people ask me, I sometimes do catkin make, sometimes I don't do. So whenever there is a C++ node, you have to do catkin make. If it is a Python node, it's okay if you ignore that, because Python takes the recent version of the script, but C++ nodes take the build version of the script. So that is the reason you have to do catkin make or catkin build. Okay, so I I guess there should be some error because I have some expired package lying around. I guess we should remove those. If it works, it is great. If it not, yeah. So this is not made for ROS Noetic. So this malloc is not made for ROS Noetic. Let's see if it works on our robot. Is our robot alive back? Yes. So uh, I guess it should work on my virtual machine as well. I will bring the USB camera. Just hold on. These things are already shown in the previous session, but still I am showing it to you. It's just for everyone to get a revision. So yeah, I will copy this repository. I will go into my virtual machine. Uh, cd dot dot. I will go into src. Here I will do git clone and the complete package. Hold on. Isn't my internet working on the virtual machine? I will restart it once. Just give me a moment. Uh, I just I guess there is some internet connectivity issue at my side. Please, please hold on with me, guys. If it doesn't work, then we will see some. I will shift to some other system. But at least give it a try. Okay, so let's switch on to Raspberry Pi itself. I guess that would be a better way. I guess my virtual machine is facing some network problems. Okay, power off. Where is my VNC? Is it on? Yeah, there we go. We have our Pi on boarded, and now let's check if the Raspberry Pi is running. Raspberry Pi camera is running, basically. Yeah, we have our Raspberry Pi camera running. So if you want to see the image from Raspberry Pi, what you need to do is we need to run another package, which is ROS run RQT underscore image view. So just like we used RQT graph in our previous sessions, similarly, we are using RQT image view, IMG view, sorry, VIW. Again, RQT image view. Yes. Yeah, it is complete image view. Sorry, RQT underscore image view. And if I run it, it will start a visualization thing in which I can see the view from my camera. Okay, so yes, there we go. So this is my camera. And what we will be doing is we will be tracking this yellow object and we will be trying to follow it up. Okay, so this is what we are doing. So if you are not getting this camera view, there is alternatives that you can go for. So as we are using a Raspberry Pi camera, okay, as we are using a Raspberry Pi camera, we have created our we have used the open source repository, which is this thing, Raspberry camera node. So I will show it to you on GitHub. So if I go Raspberry camera node ROS, this is the repository that we are using, in which it takes images from Raspberry Pi and it converts them into a camera system for ROS. Okay. Similarly, if you are using USB cameras, use this repository. It should work, but my virtual system is not working with USB camera, so I cannot show you today. But yeah, but in the previous session of Lentin Joseph, he has showed how to use this exact same repo. So you can go and try that out. Okay, but now we are having our camera which is working using this Raspberry camera node, so we will get into that. So now what we are getting is, if I run ROS topic list, we are getting a topic which is camera image raw. So this is like the raw image from the camera, but we want to process this image. We want to process this raw image. So how to process it? So we will be using OpenCV for it. So OpenCV is an open source computer vision library which helps you process the images. So if I, it's a open source organization as well. So if I go to OpenCV, yeah. And why is OpenCV so famous? Is because it has support for all different platforms. Okay, so it can be used with JavaScript, it can be used with Python, it can be used with Android, it can be used with iOS, and a lot of all the other programming languages. OpenCV has support for all of them. So that is the reason OpenCV is the standard for computer vision. Okay, and when you install ROS, it comes pre-installed with OpenCV. So you don't need to put any additional efforts in installing OpenCV. So today what we will be doing is we will be trying to get camera used with OpenCV. So we will be creating a node. So for that, how to create a node? So let's consider I will make a package right now. So I will go to my source file, which is cd catkin workspace src. And now today I will be creating a package which is like catkin underscore create underscore pkg, which is catkin create package, the name of my package, whatever I want. So I will say ball follower, and I will be giving the dependencies. So what is my dependency? My dependency is ROS-Pi. So it should be dependent on ROS-Pi. If there is no ROS-Pi, it will work. So ROS-Pi is the Python library for ROS. I will press enter and it will say successfully created files. So now if I go into my src, catkin workspace src, you should see there is a folder called as ball follower, and it will have this src folder in which I will make my Python file. Okay, so now let's do that. So how to make a Python file? I will first go into the ball follower package inside src. There is nothing. If I do ls, it will list down all the things that are there in the folder, which is nothing. So to create a file, I will say touch, and I will give the name of the file. Yes, Sahil, you can add standard messages as like which is dependencies, but I don't think we will be using them. But yes, if you want to add it now, there is one way you can add it. You can go into CMake list. Here you can add like find package. So there is already ROS by written. I can just add std underscore messages. So I can give space over here. So this is how you can add packages later on as well. So it's upon you if you want to add it. So here by default standard messages is there. Okay, but we won't be using it much. So we will be just using it to send the command velocity, which is geometric twist messages. But yeah, it can be done. Just an option. Anyways, we have it, so I won't be putting it. Yeah, there we go. So we were on creating a new file. So I will type touch. I will show you over here, and I can name it anything. So I will say camera.py. It will be a Python file. So now if I press enter, you can see a new file is created, which is camera.py. And if I do ls, you can see it is white in color, which means it is not executable. So to make it executable, you have to again do chmod plus x and the name of the file, which is camera.py. Now if I do ls, it is green in color, so it is an executable file. So I can open it. Let's open it in a environment which we can code it in. So this is my Genie, which is a IDE. Okay, so just like we imported few libraries in our previous thing, previous code, so we will be importing the same. So today we will be just importing ROS by geometric messages. We will be doing it later on. So I will just copy it. I will paste it. I can just save it and I can call it a day. I have created my own node which does nothing. So as I said, today we'll be seeing it in a way in which you don't know how to use it. So if I don't know, what I can do is I can just type OpenCV and ROS. Okay, so it says converting between ROS images and OpenCV images, which is the common thing we want to do. We want to we have a ROS image, we want to convert it into an OpenCV image. How can we do that? So from CV bridge, import CV bridge, and we have to do the bridging, and which this bridging converts the image messages to the CV messages. This is what it does. So it is just simple 3 lines of code. But I guess this is for C++ or Python. I'm not sure. Converting OpenCV images to ROS images.
I guess Python, because it is importing from CV. It's importing. If it is a C++, the syntax may be different.
Yeah. Yeah. So here also we have few examples of that. So let's check from the example, and we will copy pasting. So we have already imported ROS.py. These things are not needed usually, so I will just import OpenCV. We don't need string, so let's do it one by one. So I will import OpenCV. Control C, copy, copy, and I will just paste it. This is the usual programmer life. You won't be at a position where you can write your own code. Okay, this is going to help you, and in ROS, no one is going to scold you for copying because as it is completely open source. Yeah, so from sensor messages we have imported image, and what we need OpenCV. There we go. So we have imported all the important libraries. Now there is this main function that will start. So system.argv. So it starts everything like this. So let's do one thing. Let's copy the whole code and start the whole code itself. I will copy it, and we will remove it one by one, whatever is not needed. I will copy this thing and I will paste it. Okay, is there anything else that we need to change? Here is my package. The name of my package is ball follower, so I will change it to ball follower. Okay. Then here it is. Let's see what it is doing. It is starting the main system argument where it is starting the image converter. So it is initializing a node called as image converter, and it is spinning. It means it is rotating again and again, which continues the code. Now what it is, how is it converting into image converter? If we go, so first it is publishing an image topic to the topic named as image topic 2. And also it is bridging it, and there is a subscriber to the image topic. And here is another callback. So it is subscribing to the image topic. There is a callback, CV image. It converts to image message to the CV image. And it is a BGR. BGR stands for blue, green, red. And each color is 8-bit color. So that is what is happening over here. And then it is converting to specific image size, everything. And it is showing me that. So now, instead of publishing, so is there anything publisher over here? Can we see if it is publishing or not? Yeah. So here what it is doing, it is itself publishing and it is then itself subscribing. So I don't need publishing thing. So I will remove publisher. Again, I will remove publisher from here. Or I can just keep it there itself, no worries. And what we want to publish is, we want to publish it towards, where did it go? Yeah, we want to subscribe to a specific topic. So if you remember, my topic was camera image raw. I will copy this thing. Why is it lagging? Yeah, I will copy the topic name and I will subscribe to that topic. So here we go. So this is the my name of topic. It will subscribe to this. So let's save it and let's say how does it behave. So now what I can do is I can do ROS run, the name of the package, which is ball follower, ball underscore follower, and the name of the node, which is camera.py. I can start it. Let's see if it does anything. There we go. So now I have an image window. Here I can see my hand. Here I can see the object. So now we have got an image that is working. Now let's start with basic OpenCV. What I want is, I want to follow this object. So technically I want a frame inside which this object is always there. So the object should always be in this specific frame. If I move it backward, if I move it forward, left, right, so it should be there inside a box. So how can I find the box? So I will close it. I have to close the node here. I will also close this another node for some time. Yeah. Now let's find on internet how to make a box. So again, how to make a box? OpenCV. It is that simple. So next time I won't be there over here to answer all your questions. So, but Google is always there. So you can search it on Google and you will understand. So here we go. It is as simple as making, so we want a square like this. We want a rectangle. So what it is doing, it is importing OpenCV that we have already done. It is importing an image, but we already have an image. Okay. Now we are giving it a start point and we are giving it an end point. And we are giving the color. So color here it is given it in BGR, blue, green, red. And here too, the color ranges from 0 to 255. So if you search on internet RGB to hex, just a minute, yeah. Yeah. So usually colors are given in this format. If I put red as 0, green as 0, blue as 0, so there is nothing. So everything is black. If I raise red to 255, my color will be all red. If I raise green to 255, my color will be all green. If I raise blue to 255, my color will be all blue. If I have everything as 255, I will have it all white. So here let's pick up a cool color that I would like to have for my square. Or we can keep it as simple as complete blue, something like this. I can give it 0. Okay, so let's have the same thing, which but here it is, instead of red, green, and blue, it is blue, green, red in OpenCV. So you have to act accordingly. And then what it is doing, it is taking the image and it is making a rectangle. It is making a rectangle on the image with start point and end point, and the color and the thickness. So thickness here, it is 2 pixel thickness. Now let's do the same thing. So here, let's see where we are getting the image. Yeah, so here we are getting the image. So I will type in CV underscore image. This is the image that we are getting, equals to, I will take the existing image, IMAGE, and what did they do? They are making a rectangle. I will copy this thing and I will paste it. Yeah, there we go. So the image is this. We are substituting the image. What is the start point? So for now, let's give the start point as 5,5 as it is given. Okay, what is the end point? For now, let's give it 100, 100. And the color is going to be blue. And finally, the thickness is going to be 2 pixels. So I will just save this. I will start the ROS master, which will start the camera. Video capture is started, and we can start our own node. Let's see what do we get as output. So here you can see we have got a small square. So it is started from 0, 0. So the first pixel in the image, that is 0, 0 pixel. After that, if we move 1 pixels towards right hand side, it is 0, 1, 0, 2, sorry, 1, 0, 1, 2, 1, sorry, 1, 0, 2, 0, 3, 0. It's the way it is. This axis is X. So the first number is X. So the X keeps on rising. And when we come below, what it does is, when we come below, it will increase 1 in Y. So you can consider this as a graph paper, where this is horizontal is X-axis, vertical is Y-axis, and you can make. But I want this square to be in the center of my whole image. I want it to be in the center. How can I find out that? So first, to understand where is the center, I will need to know where exactly, how big is my frame. So check frame size, OpenCV. Okay, again, so get image size. How can I get dimensions? Image.shape. And here height equals to 0 and this equals to 1. So I will just copy this part of code. I will copy it and I will put it into my code over here. So I will just remove this part, as this is comment, and just make sure, as it is a Python code, your indentations should be proper. Okay, there we go. So now the dimensions of my image will be image.shape. Here image it actually means the image that we are getting. So we have to substitute that with CV image. So Control C, Control V. Okay. So my height is CV image dot shape and 1. and my width is CV image dot shape in bracket 0 and 1. Sorry, I said it wrong way. Yeah, height is 0, width is 1. So let's print it. So I will print height, and then I will print width. Save it. Okay. Yeah. Let's run it. So here, whenever my image opens, so here you can see it is looping. So my height is 480 and my width is 640. Okay, I understood. So now what we can do is we can hard code exact location at which we want the square to be. But I don't like hard coding. I like being like whatever image size it is, it will automatically scale up or scale down. So how I can do that? So let us consider, I will start this thing, PowerPoint presentation, so that I can show you. Just give me a moment. Yeah. Yeah. So let us consider this is our frame. Okay, where this is our complete frame. Here, if I go text box, okay, this is 0, 0, this starting point. After that, it is if you go to the next pixel, it will be 1, 0, as we are increasing in x. So it will be 2, 0. So this way it will go on and on. And if we go below, it will be 0, 1. So y will increase. Similarly, if we go even below, it will be 0, 2. Now what we can do is this pixel over here, it will be 1, 1. So this is like a graph paper. Now we know the complete width is around 6, what was it?
480 and 640.
640, yes. So we know it is completely 640. So if I divide 640 by 2, if I divide it, it becomes 320. And if I divide for, what was it, 420 or 480? 480.
480.
Okay, 480. If I divide 480 by 2, so I will get a coordinate. That coordinate will be the exact center coordinate. So this, if I do it 640 divided by 2, which will be 320, and 480 divided by 2, which will be 240. So this coordinate of pixel will be the exact center of the image. But I don't want the exact center. What I want is a square along the exact center. So it will be another square, something like this. Let's like make it no fill, make it red. Yeah. So let's first decide how big we want this square to be. So we have already seen it was a what was the dimension? It was 100 by 100 square. But let's think I want it to be 200 as width. So it can be anything, it's upon you. I want the width of this square to be 200, or maybe even 300 works, but 200 is good. Okay. Yeah. So I want this square to be 200 by 200, let's say. So now we have to find the coordinate of this specific corner. How can I find it? So if I take 320, if I take 320 minus 100, so it will be this pixel. Do you understand why? If you didn't understand why I am doing 320 minus 100, please tell me. So 320 is the center pixel value. If I go minus 100, it will go 1, 2, 3 minus 100 over here. So this is the value of this pixel. Again, if I do 240 minus 100, 240 minus 100, it will give me the y value. So what we are doing is we are getting 640. First, we are dividing 640 divided by 2, and then we are doing minus 100 inside that. So similarly here it will be 320 plus 100, or inside if we have to just put the end, right? So this will be minus minus and this will be plus plus. So we got this position, we got this position. Now let's implement it. So how can I implement? So here the starting position. So what I can say is take the width. So first is the width. Take the width, divide it by 2. After taking the width dividing by 2, minus 100 out of it. If I minus 100 out of it, this will be my starting position. Similarly, take the height, HEIGHT, divide it by 2 and minus 100 out of it. Okay. And I guess that is it. Yeah. So this is the starting position. Similarly, we will get the end position. So I will copy this and paste it. And instead of minus 100, this time it will be plus 100. There we go. Everything else remains the same. Now, no matter how big is the image or whatever is happening, this will remain exactly the same. So it will make a square or it will make a rectangle right in the center of the image. So now let's check it if it works. I will start this node. There you go. You have a square in exactly in center over here. You can see now what our goal is. Our this wheel should be inside the square. If it goes over here, our robot will rotate towards this direction. If it moves over here, our robot will rotate towards this direction. If it is a very big, if it is as huge as this, the robot will start moving backwards. If it is becoming very small, it will start getting closer. So this is our motive. Okay. So yeah. So I will close this image for now. It has also like made a small shape, or it is made a circle. Okay, I will remove this thing. I don't want a circle. Does it still work without the circle, or we are getting any error? Let's check once. Yeah, it is working. So we want to track this. So now we have the exact position of where we want our tracking to be done. What has happened? Can I restart it? Yeah, it is working fine. No issues. Okay, I will stop the ROS score as well for a moment. Now we want to do our yellow image tracking. Okay, guys, if you have any questions, you can put simultaneously in the chat. I will answer them. Okay, now we have to do image tracking for yellow image. So how can I do that? So let's see, color detection, OpenCV. This is the basic search term that you can search for. OpenCV. So there we go. We can detect exact colors using OpenCV. There is a complete explanation for that. So let's get through it. So here we are setting up some boundaries of the color we want to search. Okay. So that is what it is doing. It is detecting the colors in which we want to this thing. So yeah, there is the yellow color. We want to detect yellow color. So how can we do that? There is the code for it at the top. Yes. So here what it does is it takes a boundary, lower and upper boundary. So just we have taken lower and upper point for the rectangle. Similarly, it is taking like yellow se niche or yellow ke upar or kuch detect mat karo. We have to just select that yellow portion, and it takes an array. Okay, inside that it takes it and it masks with the this thing command which says cv2.inRange, and in which it is taking image, it is taking first the image, it is taking the lower value, it is taking the upper value, and it is showing me, it is masking it, and it is showing me. Okay, so now let's check it if it works. Okay, so are there any other libraries that we need? We need NumPy as the library. So let's import NumPy. So I will import one more library, import a NumPy. Okay, next we need to define the upper limit and the lower limit. So here it has, they have made a 2D this thing, what we say, what we can say for that, 2D array for it. Yeah, but we don't need a 2D array, we just need a normal array. And how you can find the range? So RGB to hex, search it on Google, you will get this. Now get onto the yellow color which you want to track. So your color, let me check if it is RGB values or hex values. Yes, it is RGB values. Okay, great. So we want to detect color from here to somewhere over here. So I can select the complete range of colors that I want. Okay, and or else what I can do is, there is one more way you can do it. So I will just, there are some plugins in which you can check the, you can take a screenshot. So let's do one thing over here. Can you see my screen? Is it visible or was it lagged?
Yeah, it's visible.
Okay, okay, fine. So this is the most simplest way in which I started, but let's do this thing. I have started a node. I have started the ROS core. I will start the node, and I will look at the image, and I will take a screenshot of this image. Okay, so I will take a screenshot like this. Just a minute. Yeah, I have taken a screenshot, and wherever the color has changed, I will take one more screenshot. So let's say it has changed over here. Okay, now I have two screenshots. I will stop this and I will show you those screenshots. Yeah, this is done. I don't want to save it. So this is one screenshot. Yeah, and now I want the exact color of this yellow. So usually I have it installed on my PC. You can download it from anywhere. So this is the color meter. So this gives me red, green, blue values of the exact object. So here you can see it is giving me different color values. So here it is giving R, G, and B complete values. So I want to detect this part. R is around 97, G is around 92. I will just note it down on a page. So R, G, and B, I will note it down. 97, 92, 6. I will take at different points, different sample points. Okay. So let's say this is one more sample point over here, which is 88, 95, and 4. I will take one more sample point somewhere over here. 102, 115, 41. Let's take one more over here. 87, 98, 15. Let's take some darker areas as well. 75, 63. Some lighter areas. 149, 160, 37. So you can take as many sample points as you want, different colored parts, but it's upon you. Okay. Now, the next thing that you need to do is, I will show you my camera and I will show you what I have done. Yeah. So I've written down all the red values, all the green values, and all the blue values. Now you need to do is take the minimum and maximum of the red values, take the minimum and maximum of green values, and take the minimum and maximum of blue values. So here My red value has gone max till 149. So my max is 149. And it has gone minimum until 56. So my minimum is 56. Okay, this is what I've taken. Now for green values, my maximum has gone up till 160. And my minimum was anywhere around 60, just 60. Okay, for my blue, the maximum was around very less. It is around 6, 4, 37. Yeah, max 41. So maximum was 41, minimum was 3. So that is your minimum and maximum values of R, G, and B. So this is how you can do it manually. There is one more way where you can do it dynamically. So if you see, if you search on the internet, OpenCV dynamic threshold. Okay, so there are some what do you say, tutorials over that in which you can dynamically select the color which you want to detect. There are some sliders, you can adjust those sliders, and you will get the output automatically. But I won't recommend that for a beginner because it is a little bit complicated for beginner. So let's begin with this simple technique that you can use. And if you get, because even I started with these kind of techniques, I went to this dynamic threshold later on. So we can see this later, but for now you can get the minimum and maximum values. And now let's put it into the array. So where we go, so I will set one parameter as lower. Here only I will put. So my lower equals to, what is my lower? It is 56, 76, 18. But remember, this is not R, G, and B. This is BGR. So it was this was my RGB. So I will first make it B. B is my 18. Sorry. Oh, sorry, I have given wrong things. So my lower anyways was 56, 60, 3. So this was RGB. I want BGR. So my blue is 3, my G is 60, my R is 56. So this is BGR lower. And similarly, I will make it for BGR upper. So my upper, what is my upper? My upper is blue is 41, G is 160, red is 149. Okay, so now I've got my lower and upper values. What is he doing next? He is masking the image and it is showing me the output. Okay, so let's do that thing. So I will copy this code. Okay, now after getting the rectangle, or before getting the rectangle, you can do it before getting that. Yeah, so we'll mask in CV2 in range. So whatever is in range of the image. So what is our image? Our image is CV image. So this is our CV image. I will replace that image with CV image. Our lower is given, our upper is given, and output will be bitwise image. So it will convert it into black and white thing like this. Where did it go? Yeah, this is bitwise conversion. So it will convert it into okay. So there is a question. Can you explain about mask? So mask means like it will remove all the other things except the part where you have the interest. So this is the complete image. Now I am just interested in this red part. So what it will do is it will just mask the red part. So mask means, see, now it has just taken the red part, and whatever is anything else apart from red, it has cut it out. So that is what masking means. Okay, so it has eliminated everything else. So now I will just put it into what is doing after output. Just let me check the code once. Uh, it takes the output. Okay, technically we don't even need to mask it, but okay, fine, no issues. We'll take the image, CV image, mask equals to mask. So that is what we are doing. Okay, now it will show the image. So we want to see the output image. So where is it showing? Where are we seeing the output? So yeah, CV2 image show, copy, paste. So here I will show processed window. So process, this is the name of the window that will pop up, and here it will show me output. So now let's save it and let's try it out. I will start my firmware bring up, and then I will start my node. Okay, there is some problem in output. There we go. So yeah, so now you can see we have got two images. One is image window, which shows me the live image, and one is the processed window, where it shows me nothing because there is no yellow color detected right now. But if I bring my wheel right now in between, you can see it is showing me the wheel. So it is detecting the yellow color. So this is the processed window. So even if I bring a blue colored cloth inside, okay, inside the frame, you can see it is not detecting anything else. If I put an orange color object inside the frame, it is not detecting that. It is just and just detecting the yellow color. Understood? So this is how you can detect yellow color. So now we have detected it. Now what we need to do, we need to find the center point of this yellow color. We need to find the center point so that we can understand that with respect to this blue rectangle, where exactly it is. We need to recognize that. So I will just close this thing. There we go. Yeah. So now we need to find the center point. So how to find a center point of a mask? So we have masked it. So center point of mask, OpenCV. So this is how usually you do. Like you check it part by part. You search for it step by step. You have no matter how big is the project, you have to divide it into small parts. Now let's search for it, center of contour. There you go. We have another tutorial. What does it do? Do we have a video? Yeah. So we have these many images, these many objects. It is taking those all parts. And then what it is doing is it is detecting the center. Great. This is exactly what we want. Okay. Uh, so contours means it is detecting the edges. But here we don't want to detect the edges. We want to just find the center value. So how is it finding the center? So let's read the thing and maybe we can find out how we are getting center in this. So what it is doing is it is making a circle. Image is making, everything is a circle. No, it is not making a circle. It is just drawing. This is drawing contours. So how is it finding center? For C in C for contours, it is taking the moments. Okay, so I guess this is not going to help us. Now let's search for some other thing. So we, yeah, find the center of a blob. This seems like a similar thing, what we are trying to do. But again, this is very, it is using contours. So let's search center of color. So center point of color OpenCV. This is more precise search. Okay. So is there anything else? Image segmentation. Yeah, so this looks something similar that we are looking for. Do we get the output? Yeah, so this is what we have arranged till right now. Do we get the center? No, there is no center point. Waste of time. Detect color in the middle of range. Yeah, this is what exactly we want. But it is getting, yeah, it is getting the bitwise. Yeah, circle location mask equals 1, image circle location. So can we try to read this code? First, it is importing CV2, which is computer vision, NumPy. It is reading the image, which is getting the height and width of the image. It is masking the circle. Okay, thickness is -1, masked image is bitwise, and image, everything that we done right now. Circle location equals to mask equals to 1. No, again. So here it has given us a simple hint, like we can find the location of mask OpenCV. Maybe this will help. Image masking with OpenCV. Yeah. So we have masked an image. Do we get the location? So mask. Okay. So it is taking some mask. And yeah, even this is failed. So maybe we can try something of our own for this. So let's try putting, this is like the image and low. Okay, fine. Let's search for ball tracking, OpenCV. Yeah, there we go. So is it helping us? No, this is just, yeah, this is detecting the ball. Yeah, now we want the center point of the ball. So how does it get it? How to get it? So let's search it. So it is green lower, green upper. This is exactly what we are doing. Okay, now it is getting the video stream. Anything else that it is doing? Yeah, so it is taking, it is, he is applying a Gaussian blur. So it is blurring the image, and then it is getting, what we say, green lower, green upper. This, it is masking, and then it is dilating everything he is doing. We don't need all those things. We just need the center point. How to find the center point of the mask? Okay, so here this contours is the only part that we might need, I guess. So if length of contour, so if first it is taking the contours, and then it is taking center equals to null. So I will just copy this code and we will try to find out. Okay, update the points queue. Yeah. Is there anything else? If contours is only our way to do this, let's search contours OpenCV. There you go. Contours OpenCV, it is detecting these things. Do we have code for it? Python. There you go. So we have the color image. After that, we are converting into binary threshold. We have already done it. We have an output like this. Now we have to find the contours. So here is like use the single channel red, green, blue. Do we need these things? No, we don't. We just need this small piece of code right now over here. Contours, it will find the contours and it will just draw the contours. It will draw thickness, and yeah, that's it. There was one more thing that we checked in the image in the beginning, which I guess will help us more better way. Yeah, this part. This is much more simpler thing to do. First, we will find the contours. So I will copy these things, copy. Once I have the output, I will process this on output files now. CNTS equals to CV2 find contours. Trash copy. So what is trash copy? Have we defined anywhere what is trash copy? Let's search what is trash copy. Yeah, so he has threshed over here. So okay, it is making a copy of the image. That is what he is doing. So instead of making a copy of this image, we'll directly give it the output file. So let's give it output out output file, and then it is some functions of OpenCV, and then we are finding contours. Okay, it is grabbing the contours. For this, he is using IMUtils, which is another library. So I will just copy this library. I will put it over here. Copy, paste. Yeah, you need to also install it. So for installing Python libraries, it is very simple. Just pip install IMUtils. So IMUtils is a Python-based library for image processing. So here IM stands for image and utils means utility. So it is a utility tool for images. So just like OpenCV, it also has a lot of things. So we are using IMUtils for that. So we have detected contours. Okay, it is done. Now we are detecting, just a minute, I will just copy this code and I will explain what we are doing one by one. After detecting contours. So for C in contours, so means it will keep on looping until we find out all the small parts. It will keep on looping and it will save it in M. So it will take just one counter at a moment. So M stands for at a moment. And what it will do is it will get the X and Y of that contour. It will get the X position and Y position. And it will also draw a shape around it. So draw contours, it will draw around it, and it will put a circle at the center of the contour, and it will put a text. So I don't want to put a text, but it's okay for now. And this will be the font of the text. This is what it is doing. Okay, and this was like showing the image. But instead of now in the image, what it is doing is it is just showing me the image. So instead of showing image, I am doing all this in output. So I will replace this image with output. Copy, output, output, output. Now if we see the output, let's see what we get. Okay, I will start first my ROS core. And here I will start my camera node. What is the problem? OpenCV error. Okay, there was some problem. Let's try to read the problem. What was it? Unsupported format. Find contour supply. Okay. So we are providing image, right? We are providing image for contours. CNTS grab contours. Thresh.copy. So let's do this processing on our image. Whatever he is doing for threshold, let's pass the same. So I will copy it and I will put it over here. After my output, it is converting. So we will convert our output file. It is blurring it. First, it is converting the BGR image to a gray image. Then it is blurring it. So I will blur the gray image. That is done. Then it is adding a threshold. Okay, no worries. It is adding to the blurred. And finally, what it is doing is it is providing the thresh.copy. So let's try this thresh.copy. Instead of output, let's put thresh.copy. Yeah, there we go. Now it should run. Yeah. So right now there is nothing. As soon as I bring yellow, you can see it can find a lot of centers. What is the reason? It is finding a big object. So now as soon as it becomes small objects, it will find a lot of more sensors. So if it gets very small, it will find a lot of centers. But if it is a big object, it will find the proper part. Okay. Now what we want to do is we want to just get one center. Even the one value of the center is okay. We don't need to track the complete part. So how can we do that? So now let's get to one point. So how can we do that? We can just take it by the first thing. So here I will take, instead of drawing it on every part, I will draw just one part. So here, yeah, here instead of C, it will be 0. So it will take just the first contour, and I will put it over here. C moments what? Just a minute, I am doing something wrong, I guess. It was C, right? So let's try to find out what it is doing. It is finding contours for scene contours. So this will be just 1, 0, 1, 2, 3, 4, all these things. Okay. Yeah. So I will just, if I just replace this with 0, will it work? Well, it should work. Let's try out.
Shouldn't it be CNTS of 0?
It can be anything. It is just one. Wait, what you are saying? Here, CNTS 0.
Yeah, I was saying instead of 0, shouldn't it be CNTS of 0, as in CNTS index 0?
CNTS, something like this. Okay, let's try it. Yeah, but still we are getting a lot of centers because it is plotting on every, like even if we are tracking just one, it is plotting everybody. So where else it is given as C. Okay, so it is plotting these points as well. So CX, CY. So let's do one thing. Let's keep it over C here itself. C. And here I can take CNT as 0. So Whenever I'm bringing, it is like, just a minute. Okay, I understood. Mhm. M equals to CV2 dot moments, and it is taking first, and CX and CY, it is taking from the moments. So instead of directly taking 0, we can just provide it for C. Okay, 1. Yeah. So now we are able to track it, but it is not finding center. So let me just check it once. So we are providing. So here it was C. Anyways, though, no matter if we get multiple centers, we can just take one center from it. So let's do that part first. And circle output. Okay, it is typing center. That's fine. There is some major flaw in this code, I guess. Right. Okay, placing white circles at CX and CY. Okay, got it, got it. So these CX and CY are the positions of what we say the center. Okay, so even if we directly print the positions of the center, we can get the center. So even if I don't do all these things, I can directly put the center CX and CY. So if I print the location, so let's do one thing, print. What we will print? We will print CX plus we will give us some space, and plus we will print CY. And these CX and CY should be in string format. So str, str. So these are string formats. Okay. So now let's check this part. So now we are just printing the center position. What is global name CX is not defined. Okay. So it is taking this CX. Okay. Okay. So we will just define global CX over here. Global CX, comma, CY. Okay, or else, okay, the problem was CX and here the name was C capital Y. That was the problem. We don't have to define it over here. Again, the same local variable referenced before assignment. Where did it go? Okay, so if so again I will put this thing, or else even then it should work. I am just putting it at the wrong place, but still, if I can put it over here, no worries. It was just it was not able to track anything, so it was happening. So now it, yeah. So we are getting the some values, but it is like it is showing errors continuously. So what is the error? Image converter callback. Okay. So anyways, we don't need this publisher. So we will remove this publisher. We'll remove this publisher again. Okay. Does it solve our error? at least a little bit. Only now the thing is it cannot be divided, float division by 0. Okay, so we are not getting the exact positions, but what is happening is whenever it is the thing is to divide by 0, it is showing the error. So no worries, we can at least get some center values. Now we know the x coordinate and the y coordinate. So depending upon that, we can tell our robot to go forward or backward. Okay, so now what to do is to remember this thing differential.py. Here what we did was we gave it command velocity. So we will be giving it in that way. Okay, so now I will copy this thing, differential.py. I will be publishing geometric messages. Okay, now to publish geometric messages, we were using a script called as teleop twist keyboard. Teleop twist keyboard. Okay, if you go on to their GitHub, you will find this Python script which runs, and here they are publishing this geometric messages. Okay, so now whenever I press I, it goes forward. For J and L, it moves left and right. So let's see where it actually works. So first, it starts a publisher. So now let's start a publisher for ourselves for the command velocity. So where did it go? Yeah. So here we'll start a publisher. Okay. So here we have the publisher. Wait a minute. It has all spoiled the complete indentation. Just a minute. What is it? It's self.publisher, self.publisher. Yeah, now this will work. Copy equals to controls V. Yeah, there we go. So now we are telling it to go somewhere. So how can we tell it? So for publisher, we have to tell it like X, Y, Z, and TH, speed and turn. So everything that we have defined yesterday. So X is like forward, Y, our robot doesn't go sideways, so we don't need Y and Z. But usually people keep it so that you, if you have a omni wheel robot, if you have a Magnum wheel robot, you can tell it to go at a specific location. And next thing is, see here, you can publish linear X, linear Y, linear Z, all these things. So here it publishes specific topics, like it publishes at what speed it should go and where it should go. So that is what it publishes. So let's see where exactly it is getting the key bindings and what is doing. So yeah, try it waits for subscriber and it updates. Like whenever it gets the subscriber, it updates everything to 0. Okay, now it prints the message. What it prints the velocity, speed and turn. How does it print the speed and turn? So it gets the key. So it gets the key, whatever user presses the key. And if key is in move binding. So move binding, what is move binding? These are the move binding. So if that key is I or O, J, L, any one of these, if it is the key, what it does is it takes the 0, it takes the 0, 1, 2, 3 value. It takes X, Y, Z, TH. So X is linear velocity in X direction, Y is linear velocity in Y direction, Z is linear velocity in Z direction. Usually we don't need these two, but TH is theta. Theta is the angular rotation. So here, if you want your robot to move left and right, you need the angular thing, right? So what it does is it takes these things. And what does it do? It goes to the move binding and key. So what is move binding inside key? So here move bindings inside key. Let's consider if we are pressing J. What will do? So it will go to J. So where is J? Just a minute. Yeah, so it will take the move binding. So it is the move binding of it is 0, 0, 0, 1. It is taking these things. So what is 0, 0, 0, 1? So the first is, where did it go again? Yeah, the first is X. So linear velocity of X is 0, means it is not going forward. Linear velocity of Y is 0, so it is not going sideways. Linear velocity of Z is 0, means it is not going up and down. Just theta is 1, means it is going towards left side because it is 1. If we press L, it is -1 because it rotates towards opposite direction. It rotates towards right direction. So if we want to go towards left direction, it is 1. If we want to go towards right direction, it is -1. It's that simple. And what it is it is providing that values to th. So now let's see where the th is used. So here it is publishing. It is publishing X, Y, Z, and th. So now let's take a simple example of publisher and subscriber. Publisher Python. Okay. So let's go over here. We have already made a publisher. Let's initialize the node. So I can put this thing. ROS Py init node. I want to say it. What do we say? Let's keep it name as Docker itself. It doesn't matter. Okay. And here, whenever we have to publish it, what we say is pub.publish hello string. So here it is publishing a string message, but we want to publish a geometric twist message. So how does it publish a twist message? So here we make a twist. So twist equals to twist that we do. So if in the starting you see we are importing geometric message, which we have done over here. So now we define the geometric message. Yeah, twist. So here I will define it. Let's define it just above over here. Yeah, now we have defined it. Now what we have to do is twist dot linear and theta. These are the important things that we want. So I will just copy them all for first, and then yeah. So linear will be there 0, and our angular of Z is what we want. And then it is publishing the twist message. It is that simple. So here at first we are keeping everything 0, but depending upon what we track over here, depending upon that, we will see if we want to go left or we want to go right. So here after this thing, after making the rectangle, after showing you processed window, I will publish the twist message. But what will I publish? So here if we read again, self publisher, it is publishing twist, but in what way? So here it is telling these are the copy pasted values. So I will copy this. If I will add a condition, so if cx is my technically the center of x and means x direction. So if cx is greater than if cx is greater than this value, the width, like if it is in the box. So if width, yeah, and what was the extreme value of the width? Yeah, this was the width. Yeah. So if our CX, like the center of our ball, is in between the minimum and maximum of the width, if this is true, then what will happen is uh, it will stay. So it will
That
not
width
rotate.
100, right?
What?
Width by 2 plus 100.
Oh, sorry. Understood. Or else we can make two conditions. Okay. So if yeah, if CX is less than minus 100, if it's less than minus 100, that means we have to move towards left. So how should we move towards left? We have to increase the angular thing. So copy, paste. So we want to twist, we have to give angular rotation. How much we will give? What was the tortoise bot runs at an angular speed of 0.7, I guess. Let me just check. ROS run, tortoise bot control, tortoise bot teleop key.py. Yes. Yeah. So if we give 0.7 as the turning speed, it will rotate. So now let's give it 0.7 itself. So angular Z is 0.7. Another condition if we will add elif Cx is greater than plus 100. Plus 100, it will rotate in the right direction. This ball is going towards right hand side, so it will rotate towards right direction. So it will publish minus. Else, if it is anything in between, else angular will be 0. Okay, so angular will be 0. 0.0. So now we have defined our twist. Where did we do it? Yeah, here we have defined our twist, and at the end we are publishing twist. So now just save this thing and let's open up, and let's open up a new terminal. Wait a minute. New tab. There is some indentation error. Did it fixed now? What is the indentation error over here? Maybe this part. Yeah. Still. Let's Control X. Let's do it over here itself. I will change all the indentations. If CX, yeah, that's right. That's right. Elif. And finally the else. This should work now. Still there is some problem. Can anybody see what is the indentation problem? I will type this all things once again. Height is given proper, yeah. Width is given proper, correct. If is given, this is proper. Elif, else, publisher, CV to image. I guess everything is properly done. Now it is giving error over here. I will just open this in auto indent. Just a minute. I will open this in Thony. Yeah. Yeah. Text editor. There is no auto indentation option in this. We have like changed some indentation previously, I guess. Let's go back and try to code it once again without any of these things. I guess while adding conditions, we did some issue. So does it work now? What has been done now? Okay, we are not publishing anything, so that is the reason it is showing me error. Okay, I will name this node as camera itself because this is a camera node. Camera CMD because it is giving commands from camera. Have we initialized the node? Yes, we have initialized the node. Now at least we don't have indentation problems. So now we have the center value. So if, no, not here. After getting the CX and CY and height and width, if C capital X is greater than this thing width, copy, paste, then it will publish this twist.angular.z equals to twist.angular yeah, equals to 0.7. So minus because it is greater. Let's add just this one command and see if it works. Is there anything else that I am missing? Where is it initializing? Just a minute. Control F, INIT. Okay. Copy. And I will paste it over here. What is it? Self.publisher. And then the name of publish.twist. Publish. And we will publish twist. Are we getting any errors currently? Let's check. Wait. Even then, it is facing giving some indentation error. Okay, so now what is the error? Where is it initializing? Control F, INIT. Image converter. Okay, so we are not working on image converter right now. So we can remove it over here. But apart from that, does it work? So I guess we were copy pasting it from there. That was the reason it was putting some indentation errors. Okay. So for now, what we can do is twist.angular.z. So we have to publish it over here. Where did it go? Yeah. Twist.angular.z equals to minus 0.7, and I will add elif cx is less than width /2 minus 100. If it is out of that scope, what it will do is it will publish twist.angular.z equals to 0.7 positive, because we want to move towards other side, and else what it will do, twist.angular.z equals to 0. So else it will stop, and after that we have to do self.publish what is it, publisher.publish, sorry, publisher.publish, and we are publishing twist. That's it. Okay, inside publishing twist, what we can do is yeah, even that is enough. So let's try it now. Again, this time for greater than. What if I remove this part? Anything after that is getting error. Ha, it is working here, but it is not working over here. Self.publish, publisher.publish in bracket twist. Yeah, so here if I do command velocity, so wait, instead of doing that, I will add conditions all over here. Else twist.angular.z equals to 0. I hope we don't get error now. Again.
You can try putting bracket after if the conditions.
Like this.
Yes.
These brackets are right, right? Yeah. Mm, no, still it doesn't work. We are getting some serious indentation issues over here. I don't know what problem it is facing over here, but I think we should like indent all this again, and maybe that will fix. It is time consuming, but I don't see any other
Yeah, the
solution for
previous
that.
indentation seems to be the double space, and
Uh,
the one we were doing was a tab.
okay, yeah, maybe because of that. So these twists are okay. This is okay. This is okay. Yeah, these match the above indentations. Yeah. Hmm. Now it should work. Maybe that was the issue. Now for twist. I guess you have to do it all. There is no shortcut for it. Okay. Wait, I will do it one by one. By default, what I will do is I will put cx and cy as 0, 0. Cx equals to 0. Cy equals to 0. Instead of 0, I can put it the centers, or else it's okay. No, no, no. If it's not okay, because it will take this thing, right? So 640, yeah. So I can do the CV image at the before this. Control X. And this even before that. Yes, I guess this will work now. So here I can take it exactly GI height divide by 2, and it will be, sorry, it will be width. WIDTH width HEIGST. So we will not get that error we were getting, that red color, because we are defining it. Yeah, there we go. CV image is not defined. At line number 30, 37. CV image. We have already defined it. Okay, I guess it is because of the this thing. Just a minute. ROS by publisher. Hello, can you hear me? Am I audible? Yeah, okay.
Yes, one.
Yes.
Sorry. ROS by CV image. I guess because of this thing, it is showing some problem. Example, yeah. Bridge CV. Okay. Image publisher, ROS by image publisher to publisher. Here is another publisher, which is a command velocity publisher. It is a bridge. Okay, that is done. We have taken all these things into consideration. Hmm. Again, CV image is not defined. Is our main node running? Yes, it is running. Image publisher. Okay. Right. Callback. Try. CV image. Is my spelling wrong somewhere? IMAGE. It is exactly the same. Let's remove this twist thing for a moment. Okay. I will remove this publisher. And instead of removing, I will just comment it all. Comment. Lower upper, let it be. Mask output, yes. Gray. Blurred. Okay. Will this work or not? I guess we have done some fundamental wrong thing in this, and that is the reason it is not able to detect the camera image as well. Mm. Mm. Height, width, okay, it's right, it's right. Let's start from scratch in a new code and we can find out that way. So let's make another node, tuch camera2.py this time. Let's make it executable, chmod plus x camera2.py ls. Okay, we have it. Let's open it in Genie. There we go. Let's start with this simple script where we have an image publisher and subscriber. Copy. And there we go. Wait a minute. I guess I didn't copy. Yeah. Copy. Paste. Everything is done. Yeah. The subscriber should be different. The name of the topic, image topic. So this is the name of image topic. Control C, Control V. Anything else to change? Everything else seems fine. Okay, I don't want this circle. Apart from that, everything is fine, I guess. Yeah, I will save it. Let's run the node camera2.py. Okay. Ball follower camera2.py. Okay, the package name, my package. So the name of the package is ball follower. Yes. So it should show an image. Yeah, everything is working over here. Great. Now let's start with image processing that we did. First, we took the lower and upper values. We masked it and showed it in output. That is what we did. Copy. We did it after printing the error, right? Yeah. Done. And then what we did was we found out the contours, we blurred it, and all these things we did. And we were printing the centers. Okay, now we are printing the centers. Apart from that, is there anything else? Yeah, we want to show the processed window, which is the output. Indentation error. Oh my God. We have to do it again, I guess. I will just write it one by one. No need of copy pasting, I guess. So, yeah. So what was it? Can I open it in two separate windows? I'm afraid not. Okay. So it is lower, upper. These are the two things. Okay. We need to just make sure the indentation is correct. Lower, upper. Yeah. So it is done. Very good. Let's add 2 to 3 lines at a time. And let's see if there is no indentation error in that. There we go. So there is no indentation error over here. Now let's do these things. Copy. There you go. Going great. Copy this. Paste it. I just hope we don't get any error now. There we have it. So here, I guess I have to write this from scratch. So yes. So for C in CNTS, C in CNTS. Now I can manage once the indentation is done over there. Yes, that can be solved. No worries. So what is the error? Immutils is not defined. Yes. So here we forgot to import this thing. Immutils and geometric messages. There you go. Yeah. Working. So what was the error message? So we can get the value of the center as well. And what was this thing? Float division by 0. Okay. This we cannot avoid because yeah, there will be some this types of cases. Okay. So now simply what we need to do is well, yeah, we have Cx and we have Cy. Now we have to put our conditions. So first of all, let's make a publisher, another publisher. So from the same node, we are putting another publisher. Yeah, there you go. Let's try this out. Do we face any problem in this? Is there any kind of error? No, there is no error. Okay, fine. Next thing. What we are doing next thing is, after getting publisher, we are putting these twist things, twist messages. Okay. Now, once we have twist messages, remains our conditions and our publisher. That's it. So I guess it's better to write the conditions manually. So if C capital X is greater than what we say. twist dot angular z, twist dot angular dot z equals to minus 0.7, else twist dot angular dot z equals to 0. I guess this is good. And the publisher, that's it at the end. Which one else? This was the else. Okay. And what was it? Twist dot angular. Okay, it is working now. We have to add one more condition, which is else. I hope it works right now as well. For else, twist dot angular dot z equals to 0. Moment of truth, it is null. Does anyone know how I can solve this thing? So I'm not using tabs technically. So here it is tab, here it is, and if I press, yeah, these are tabs. What is this? Even this is tab. Tab. What is this? It is tab. Everything is tab over here.
Can you again just like remove?
Yeah, these are spaces. Yeah, these are spaces. I got it. So even if I remove 1, 2, 3, 4, yeah, I guess now it will be stuck. Okay, wait. 1, 2, 3. These things are okay, I guess. Yeah, 1, 2, 3, 4, 5. Yes, these are single things. Yeah, 1, 2, 3, 4. Yeah. No error till now. So I guess we are done. Yeah, there we go. So now we are getting the center point of the this thing. Whenever we don't get error, we are getting the center point. So now let's see. Let's echo the command velocity topic. So we'll do ROS topic echo /cmd underscore vel. So what it will do is it will print what is the velocity going. So right now it is, you can see it is 0. But like I will show you the camera as well and the ball. Yeah. So whenever my this thing is in center, whenever it is getting detected, Why is it hanged? Yeah. Whenever is it in center, it is giving 0. But as soon as it is greater, it is telling it to minus 0.7. So what will happen? My robot will rotate like this until it's in center, and it will again tell it to stop. So now we have to add the similar condition for going left. So now let's do that. So it is just as simple as this thing, in which we add one more condition, making sure our indentation doesn't fail now. So elif C capital X is less than these thing, but this time it is minus. Okay, so yeah, minus, and here we tell our robot twist angular dot z equals to positive 0.7. I guess it should work now. Indentation error. Okay, no worries. 1, 2, 3, 4. Now we know how to solve it. Yeah. There we go. We have different ROS topics. Yeah. So whenever the wheel is in center, everything is 0. Whenever wheel moves towards this side, it is minus 0.7. Again in center 0. If it goes on this side, it is positive 0.7. So now hopefully our robot should able to see this ball and track towards that side. So now I disconnected my battery from the robot. I was just powering Raspberry Pi. So let's do one thing, power up the Raspberry Pi through the battery so that our wheels will also move. So this time my robot will be actually moving on its own without any assistance from me or my camera. So let's do that thing. So that you can also see it, I will start my camera. So I guess you should be able to see this thing. Yeah. So I have book. Oh yeah, yes. So this is my robot. This is my wheel. So now, if everything goes well, our robot should able to see the wheel and it should be tracking it and it should rotate on its own. This time it won't be like doing anything else like following it, but we can add that functionalities as well. So now let's, everybody can see my screen, right? Tortoise bot
Yes.
brings up. Yes. So Tortoise bot firmware and bring up dot launch. This will start the camera. And next our camera node that will do the tracking, ball tracking node. So new tab, ROS launch. What was it? Ball follower and camera 2.py. 2.py. I will open one more tab. Okay, not ROS launch, it is ROS run. It's not a launch file, it's a node. So we have to do ROS run. Yeah, there we have it. So this is the camera view. And let's echo the topic as well. So I will open a new tab. ROS topic echo /cmd_web. Yeah. So now it is 0. I will place my hand. Okay. So the wheel is in center right now. If I move it towards this side, so the robot will try to follow it. So as you can see, the angular velocity right now is very fast. That is the reason. Wait, yeah. That is the reason the robot is moving too fast. and it sometimes it misses the ball. So let's do one thing. Let's keep it a little bit slow. So we will go into our ball follower script, camera 2.py. Okay, we will open it in Genie itself. Okay, yeah. And instead of giving it 0.7, let's give it 0.3. I guess that would be a perfect speed. Let's try it now. Yes. So now, if I show it, the robot, no, 0.3 is very low for the robot. So let's give it a little bit higher. I will stop this script. Rest, I will keep everything running. And here I will increase it to 0.5 maybe. 0.5. Let's try this out. Placing the robot in center. So you can see it is following the wheel. So depend upon where it sees the wheel, it will follow. So right now it's oscillating because the wheel was the threshold area that we have kept. It is very small. So if you want, you can increase the threshold area. That is one option. So we have kept it just 100, right? 100 by 100, 200 by 200 box. We can increase it. If you want, you can increase the threshold or something like that. So that is all you can do with this thing. And if you want to go, if you want your robot to go forward and backward, so depending upon the size of the detected object, what you can do is you can give it a linear speed. So I guess it's been long since we, like, it was supposed to get over by 7, but due to some technical errors, we have to extend it. But yeah, apart from that, if anyone has any questions, any problems that we faced right now, so you can just put it in chat. I will be there to help you out. And if not, then we can conclude. So we'll take a couple of questions if you have any. If you guys want this code, there is a better version of this code. I will show you. If you go to github.com/tortoisebot, sorry, github.com/RigBetel labs. Yeah. On tortoisebot, there is a better wall follower, like object following code. Yeah, so currently it's private, but we are going to make it open source. So it is object detection. So it is similar to this. We are taking camera input, and like based on what we receive, we are providing it where to go. So everything is there inside this object follower, and there is one more code similar to this. Yeah, so there is object follower, lane detection. So all these things are using OpenCV. There is a waiter based robot, so you can check that out if you want. So I will show you a video in which it is properly working. So if I go to instagram.com/RigBetel Labs, so there we have a video of it in action. So it was in simulation first, but here you can see it is following this house object. So it is making a circle out of it and it is following it. So it is going forward, backward. In whatever direction you put it, it will follow that. So this is the simulation of tortoise bot. So it is already available over there. Yes, Sahil, I was importing different modules in camera.py. So this is just one script that we have wrote today. Camera.py, we have different modules. So we do computer vision in this, and we also do command velocity. So command velocity sends the message. So the same thing that was running in simulation, the same thing is running on the real. To give commands to the motors. So for giving commands to the motors, we already wrote this differential.py. Right. So this differential.py used to give commands to the motors. So whenever I start bring up.launch, it will start differential.py in the background. And if this, what does it do? It just gives the command velocity. So once we send the command velocity, it interprets the command velocity and moves the robot. Any other questions? Kamalnath asks, I have made a prismatic joint along Z axis, but whenever I launch gazebo, it falls. So Kamalnath, you have to tune the controllers for that joint. So there are some tutorials, or if you search how to tune PID controllers, how to tune PID controllers ROS. You have to add controllers and then you have to tune it. So there is a great tutorial by the Construct on how to tune controllers. There is a whole video, there is complete given guide, so you can follow this. So if you don't have controllers, you won't have any control over it, so it will fall down because of gravity. So if you add controllers, it will have effort controllers. So using that effort, it will keep it at a certain height, whatever you give it. Any other questions? Anything general in ROS or anything about how to get started with ROS? I already explained all these things to you, but yet if you have any similar kind of questions, you can ask me now.
Pranshu,
Yes.
like raw simulation and everything is done. If you want to implement everything on hardware, so the things that were new, the Raspberry Pi is new for me as I've never worked on it. So and LiDARs and everything. So Tortoise would be a great start to learn the packages info right from there.
Yes, exactly. So currently the TortoiseBot package is made in a way so that you have a complete assembly guide. Okay, so if you go to rigbetellabs.com/tortoisebotwiki, so here we have given everything like getting started. Inside that, what all things you need. So you need a LiDAR. All those things are given. And apart from that, hardware assembly. So it also includes hardware assembly. And in setup, currently what we have done is we have provided you the complete image. So you don't have to worry about anything installation. So everything is pre-made for you. But we are working on the documentation currently in which we will be explaining why we have done specific thing. So right now it will be just, we have given it to you, follow as it is. But we are working on a more detailed documentation in which we will give reason for each and every step. So it will take another week or so to complete the documentation, but our team is already working on that. But if you want to get started about LiDAR camera, all the source code is given into this Raspberry Pi image. So if you download it, you will get the complete VNC image. Inside that, you will have everything. So you can get started with that.
So we can implement these concepts on our project, like which we have.
Yes. Yes, yes. So as I said, on Instagram itself, we have made a couple of things. We have shared it on our RigBetel Labs page, in which we have the mapping, navigation, simulation, all those things on tortoise. But apart from that, we have done lane detection. As I said, we have done object detection. We have done wall following. We have done a waiter bot, in which if you tell it to go at certain table number, it will go there autonomously. So all these things are already done, and our team is still working on more and more new packages. So yeah, you can go through that, and if you want to modify it according to your needs, you can do that. If you want to use it as it is to learn, it's best way to do it. Kamalnath is asking, will increase of friction to the joint will help, not fall? No, increasing the friction will not help, because increasing friction will just add friction to the joint, but still you don't have controllers, so it will be considered as like you won't have anything stopping it from falling. So you have to add controllers.
I had one more doubt.
Yes.
Uh, so, like, there's one thing that we can do to control a bot is manually using the teleoptist keyboard, right? And the other thing is that we can either feed the coordinates like we did in IRCKT of the table, and the bot used to travel there. So, is there anything, something like that we can, like in real time, we can say the bot to go at specific position and it can go over there, like fully autonomous thing.
Okay, so for that you need the odometry value of your robot. Okay, so in IRCKT, what you did was you just told it to go forward for a couple of seconds. That is what you did, right? So apart from that, what you used to do, you used to give the odometry value. So you have to provide the position of the robot, and based upon that position, you used to tell ki, ha, robot is at 0,0, go at 1,1. So after that, it used to calculate and go. So similarly, that 0,0, that 1,1, these are responsible of the odometry value. So you get odometry from your robot. So in TortoiseBot itself, we are publishing odometry using a SLAM technique called as cartographer. So that provides you the odometry reading using the laser data. So if, either you can use a LiDAR to get odometry, or you need an encoder to get the odometry. So you have these two options: use a wheeled encoder, or you can use a LiDAR. You can use both the things. Once you get odometry, then you can give it any coordinates as you want.
So we can give coordinates through command lines, through CMD, or
Yes.
or like maybe if we are making a speech recognition bot and we have pre-fed it of a specific location. So that's the hard code, like that we
Yes.
did for IRCKT. We gave the table specific coordinates and then it used to go over there. But in
Mhm.
real time, if we want to call a robot at some location, so autonomously, so that can also be done through odometry,
Yes.
right?
So in that odometry, yeah. So let's say you have fed some positions in your house, like hall, kitchen, bedroom. Okay. And if you say voice command, so you can ask, like you can put a Python code for voice command. So if it recognizes the word bedroom, so it will check what is the location of bedroom, and it will give you that specific coordinate. And then your robot, it will publish to the robot, and then robot will go to that specific coordinate. You can do it in that way.
This is similar to the thing which works in warehouse robots, right? Like
Yes, kind of similar, but there is a lot more complexity into it. So it does obstacle avoidance at the same time. It has to do path planning, in the sense it has to, it doesn't go just point A to point B. While going from point A to point B, it has to stop at point C, D, E in between. So it has to do that planning as well. So, but basic thing is similar.
Okay, thank you.
Yeah, so if there are no any questions, then we can conclude. Kamalnath has one more thing. So can you please make a detailed implementation of waypoint navigator, GPS based navigation like robots done by ClearPath robot? So Kamalnath, there are already like all the things available. So on the internet, I don't need to do anything like such. So if I search waypoint navigation ROS, See, there is a package for that, follow waypoints, in which you have to just give a coordinate. So you can say waypoints, and what is the path ready, path reset. So here, if you go through the documentation, you will understand follow waypoints, waypoints.launch. Just open it. Let's search it. So what was that? Follow waypoints.launch. Let's see it. Okay. So let's go into launch, follow waypoints.launch. What it does, it adds the topic initial pose, and it adds the pose array waypoints. So where is the waypoints? So let's search where is the waypoints. So follow points, follow points, follow waypoints. Okay, done. Understood. So now if you go back, see, follow waypoints. So there are all the waypoints should be written somewhere over here. Current pose, it is getting the current poses. It is saying reached. Okay, follow waypoints, publish topic. Yes, so it is publishing the XYZ orientation. The current pose, where are the waypoints? Okay, it is the action lib server. Okay, got it. Just a minute, I will show you. So if it's the action lib, does it have anything? No. There should be some Python file telling all the waypoints, or else it is taking, okay, it is taking in the RViz. So in RViz, you are giving them waypoints. That is what is happening. But I guess there is some follow waypoints.launch is done. Nodes, what does it have in node? Waypoints, images, saved path. Okay, saved path. Let's check what is there. Pose.txt, nothing is there. Okay, so currently this takes it from RViz, but yeah, but I've seen this what is it, this simulation by ClearPath Robotics. So you wanted exactly this thing, where it does GPS waypoint navigation and in continuous simulation. So they have their own GitHub repository. There you go. So yeah, outdoor waypoint navigation. Just go through it. There is all the things are given in detail in ClearPath Robotics. So you have simulator, you have navigation, you have waypoints. For navigation, it is all the parameters and things. Let's check in waypoint if we get something. Yeah. So this is the initial XYZ. This is role picture. Okay. Anything else? It has SRC, GPS waypoints. It is very detailed thing, right? Everything is available on internet. Just go through it, because if I start going through it, it will be very complicated for now. But it is possible. Even we have done it on RigBetel Labs, but I cannot share the complete thing with you. But I can show you a glimpse of it. We did it for an internal project. RigBetel Labs. Okay. Yeah. I can go into the repository. Where was it? Yeah, this was pick and place bot that we made. So we made our own pick and place bot. It had waypoint navigation. So if I go into navigation and pick bot nav, yeah, it had some configuration files, room waypoints. So we provided it like this. So this was the pick table, this was our waypoint, and this was the drop table. So we provided it these points, and now it used to go over there autonomously. So this is possible. Okay, we have done it. If you want to know more in detail, you can like contact me personally on my email, and I will help you out over there. But this is how you do it basically. So in which I have given two waypoints, pick table and place the drop table. And this we done on Melodic itself. Whatever you can see over here, we have done it on Melodic. There was not kinetic or such thing. So yeah, again here we have used to give the pose and everything. I guess there is one more branch in which it had everything, full testing, I guess. Yeah, here we had multiple waypoints. So we had multiple drop tables, we had multiple pick tables. So first it used to go over here, then it used to go over here, then it used to go over here one by one. After that, it used to go to the drop table, first here, then here. So this is all what we done. Yeah. So I hope we can conclude today's session. Can you please show simulation of it? Sorry, Kamalnath, I cannot show the simulation, but it was something like this. You can understand it from here. So this was the simulation environment. You used to get the arena, then you can map it. Once the map is saved, then the complete thing was autonomous. So it used to go over there autonomously. It used to pick up things. It used to place things. So that was completely autonomous. So even if I show you a video, it won't like do anything because it was completely autonomous. You don't have to do anything. So it looks like a clear path robot, but it is not a clear path robot. We designed our own robot for this. The color scheme was similar, but again, it is not the clear path robot. It had a tray behind it so as to keep stuff. So first it used to go over here. It used to pick up some things, and then it used to go over there, and it used to place it over here. So that was what we did. Okay, then I guess there are no further doubts, so we can conclude today's session. And thank you, everyone.
In the case of you are developing a robot for hello.
Yes, go ahead.
Is my voice audible?
Yeah, it is audible. Hello.
If you are your voice is, if I am developing a robot to clean my house, so each and every time it need to start from its home position. Whenever if I power off my robot, and then when I switch on the power for the robot, after power off,
hello.
It need to know autonomously. Then it need mapping and implementing all the autonomous packages.
Yes.
What can I do for it? Like in the case of if the power gets cut down in the
okay, so for that case you need to implement on your SLAM technique. So whatever you are doing for SLAM, so in each house, once you have created the house of map of the house, then your AMCL should be as powerful so that your robot localizes itself, no place where it is. So if you see auto AMCL, auto localization, you will get a lot of packages in which the robot checks its position at different places and it automatically localizes itself. It knows at what position it is. And once it knows at what position it is, it can resume its work.
Okay, bro. But after power off, it will be whenever I power off my robot and switch it on, it's like in a home position, but in the simulation. But the robot is really in the home position.
Trailing home position
in the real world.
Trailing means?
Like let us consider now I am starting
Kamalnath, your voice is cracking.
Launch and move-based.launch to run my simulation. And
your voice is cracking in between.
Building on top of that, like Pranshu, like you said,
is my voice audible?
Okay.
Yes. Yes, Surya, you were saying something.
I think Kamalnath wants to speak. Anyway, so on building on top of that, like as you said, like we can use AMC, like a Monte Carlo tree search for locate, so that the robot can locate itself in an environment. Yeah, and like I know it's like using a deep learning in Raspberry Pi is foolish, to be honest. But yeah, like is there any more practical way? We can't even use tracking using OpenCV in a real world, right? Like so, is there any like light model that can be used, like something like YOLO V3 light, or that can be used for object detection? Is there anything like for that purpose for locating yourself in a
For
environment?
localization, you are using tracking, you mean?
No, not tracking. I mean, I just gave an example that we can use a DL model for tracking. I'm just asking, like, for localizing yourself, like for knowing your environment where you are right now, instead of an Monte Carlo. Is there any light DL model?
No, I guess I have not researched about it that much, but yeah, but most of the time AMCL worked for me. If you tune some parameters of AMCL, it will recognize itself in any environment. So usually what happens is the default AMCL particles, it localizes in a very small area.
Yeah,
So
exactly.
if you have a big area where your lidar is reaching at a very high point, so you can take full advantage of it, and you can tune the AMCL particles so that you localize itself in a bigger area. So it will help you in a better way that you can do. Because I have mostly worked with AMCL. The thing that you are saying, like going into deep learning and those things, I have not done yet.
But yeah, I mean, tuning the parameters of AMCL is really painstaking. You have to just sit down for one environment and then work on that for days together, just to like find out if you are, I mean, not days, but yeah, it's painstaking. For you have to work for each environment, and you can't use the same parameters and use it somewhere other. So
Are you
thought
talking
of,
about AMCL parameters or navigation parameters?
no, I'm like tuning parameters of AMCL, like
No,
let's
AMCL, once you do it, it works for everything. You have to just make it for once for one robot. That is what you need to do.
yeah.
Yeah. Like were you working every time on different robot or same robot?
No, like it was a simulation, I mean, on the same robot.
No,
So
because if you make AMCL once and if you tune it according to your robot, and if your make it for the bigger environment. If you make it for bigger environment, and if it can localizes itself in a bigger environment, in all other small environments, it will work perfectly. But if you tune it for smaller environment and then expect it to work on a bigger environment, it won't work. Understood? So
yeah.
just make a simulation environment which is huge and try to tune it over there. Once it is tuned, then it can work anywhere.
Kamalnath, are you you have a
Hello, is
question?
my voice is audible now?
Yes, you are audible. You're better now.
Yeah, bro. If I am trying to just launch gazebo.launch first and movebase.launch second, like like a navigation.launch file. After that, I am teleporting my robot in somewhere in my house to a certain distance. After it's moving there, I am just closing all the nodes and I am restarting all the nodes. So whenever I restart my node, a robot is not in my home position. So it need to come to my home position automatically whenever the node is restarted. So how can I do that? It's possible, like bring back my.
Yeah. So what you can do is whenever you restart the nodes, your odometry get reset. Okay. Now by default, your robot knows that the odometry value of your robot is 0,0, but the map value of your robot is not 0,0. So you have to give a waypoint in which, like, whenever you start the node, may it be first time or may it be 10th time, every time it should first go at that specific position in the map. You have to give that waypoint. So by default, it will launch the navigation. By default, it will load the waypoint, and it has to go at that specific point every time. Understood? So you can try it in technically it's very easy in simulation because you can put it anywhere. Just your AMCL should be perfect so that your robot within a second it understands at what position it is. Just your AMCL should be that strong. Kamalnath, are you there?
Yes, bro, I'm hearing.
Okay. So if you
I'll
want
try
any
that.
further, you can try it by yourself. Try tuning MCL. If you still face problem, just mail me. I will be there to help you.
Yes, sure.
Yeah,
Yes.
Franz, I guess
Mhm.
that was the final question of the
Yeah.
session.
Yeah.
Uh,
Sure.
yeah, thank you for that all painstaking and such like a like
It was.
extended workshop.
Yeah.
I mean, editing that stuff like in front of crowd is takes guts, honestly. Like
Yeah.
solving that. I mean, indentation. I don't know how people do that with such patience in a single sitting, but yeah, that's really commendable stuff. Thank
Yeah.
you for that.
Yeah.
Uh,
Welcome. Yeah.
yeah, that was a great session. I guess we can end this right now.
Yeah. Sure. Okay. Thank you very much, everyone. Bye bye.
Yes.